Have you ever stood by the ocean and felt the salty breeze on your face and wondered why the sea is salty while its main sources of water from rivers and rain are fresh? Today, we're going to dive deep into the fascinating journey of ocean's water and discover why the ocean's water is salty. It's a story that spans from the high mountains to the deepest parts of the ocean floor, involving processes that have been shaping our planet for millions of years. To begin with, let's understand what we mean by salinity. Salinity is the concentration of salts in water, and in the case of seawater, it's about 35 grams of salt per liter. This means seawater is roughly 3.5% salt. But where does all this salt come from? The story starts with rain. Rainwater itself is fresh because it forms from the evaporation of water, leaving salts and other impurities behind. When this rainwater falls to the ground, it begins a long journey that eventually leads to the sea. As rainwater flows over the land, it erodes rocks and soil, a process that gradually breaks down these materials into smaller particles. This process also dissolves minerals and salts, including sodium chloride from the rocks. Rivers act like giant conveyor belts, carrying these dissolved minerals and salts from the land to the sea. Over millions of years, rivers have transported vast amounts of salts to the oceans, contributing to their salinity. Rivers play a crucial role in the salinity of seawater. As rivers flow through various landscapes, they pick up different types of minerals. These minerals include not just sodium chloride, but also other salts like magnesium sulfate and calcium carbonate. The concentration of these salts in river water is relatively low, which is why river water tastes fresh. However, when all the world's rivers continuously deposit their salts into the oceans, it adds up over time, contributing significantly to the ocean's salinity. Once river water reaches the ocean, the process of evaporation comes into play. The sun heats the ocean water, causing it to evaporate. When water evaporates, it transforms into vapor, leaving the salts behind. This evaporation process is a crucial factor in increasing the concentration of salts in seawater. Over time, the more water that evaporates, the salter the remaining water becomes. This is a continuous cycle. Water evaporates, condenses into clouds, falls as rain, and eventually returns to the sea, bringing more salts with it. Another fascinating contributor to the ocean's salinity is hydrothermal vents. These vents are found on the ocean floor, particularly along mid-ocean ridges. They release mineral-rich water from beneath the Earth's crust into the ocean. The water emitted by hydrothermal vents is heated by the Earth's internal heat and is loaded with dissolved minerals and salts. This process not only contributes to the ocean's salinity, but also plays a role in the ocean's chemical composition, providing essential nutrients for marine life. Atmospheric deposition is another important factor. Salt particles and minerals from volcanic eruptions and other atmospheric processes eventually settle into the ocean. When volcanoes erupt, they release ash and gases, including various salts and minerals, into the atmosphere. These particles can travel vast distances before settling into the ocean, adding to its salinity. Additionally, winds can carry salt particles from the land over the ocean, where they eventually settle into the water. The oceans have limited outflows compared to rivers, meaning once salts enter the ocean, they tend to stay and accumulate. Over millions of years, this accumulation has led to the high salinity levels we see today. Unlike rivers that flow into oceans and carry fresh water away, the ocean's water cycle involves evaporation and precipitation, but not a significant removal of salts. This lack of outflow means that salts stay in the ocean, building up over time. The salinity of seawater has a profound impact on marine life. Many marine organisms have adapted to live in salty environments. For example, fish and other sea creatures have specialized cells to regulate the salt concentration in their bodies. Coral reefs, which are some of the most diverse ecosystems on Earth, thrive in specific salinity conditions. Thank you for joining us on this journey. If you enjoyed this deep dive into ocean salinity, don't forget to like, subscribe, and hit the bell icon